between Pertsovski, and this is my presentation of my final project for the Principles of Big Data Processing class at Harvard Extension School. My project is called Big Data Twitter Trends. For the purposes of this project, the problem statement was to use the big data processing pipeline built using AWS clusters to track how popular the hashtag big data, or big data processing keywords are by observing and analyzing trends in the number of tweets for these keywords. For this project, I had the following 4 goals. Number 1 was to answer the problem statement that I just described. Number 2 was to learn how to put a full pipeline of big data processing technologies together to create an infrastructure that is able to process large amounts of data efficiently and reliably, and then display the results in an easy-to-consume way. Number 3 was to learn how to work with streaming data from Twitter in an efficient way, especially considering the number of limitations and difficulties while working with it. Finally, number 4, I wanted to cement the concepts of this course by creating my big data processing pipeline fully on AWS clusters to learn how to connect various clusters together and ensure they're able to communicate with each other. My big data processing pipeline looked like this. My big data source was Twitter, as I mentioned before. It was followed by a collection tier implemented in Flume. Then came a messaging tier done in Kafka. After that, I created a stream processing tier using Spark Streaming. Then, I distributed indexing/search tier created in ES Hadoop. And finally, I implemented a visualization tier using the Grafana dashboard. So now, let me give you a quick demo on how I implemented all these technologies to work together. I first used the AWS Cloud Formation tool to create the necessary EC2 instances for my Kafka implementation. After I did that, I started my Zookeeper, and then started my Kafka server. After that, I created a topic called Big Data 1. Then I created a Kafka consumer. As you can see, I'm not passing any data to the consumer yet, and therefore nothing is being shown. I created an EMR cluster where I downloaded Flume 2. Here's the configuration I used for my Flume agent. Going back to the terminal, so let me go to my EMR cluster and run this Flume agent. And as I do so, we will start seeing my Kafka consumer getting the data as well. Unfortunately, as you can see right away, the data is not in a very user-friendly format. I had to create custom code to take the data, clean it, and then create a new producer that would stream it into my consumer. Additionally, I also had to create another EMR cluster where I put my Spark streaming job on. So this is starting to run, but obviously not passing any data to it, so I'm only seeing the timestamps. Start my custom producer over here that uses the cleaned Twitter data, and you can see the data looks much better. This aggregated data, as I said, is going to get passed on into the Elasticsearch. After that, I can retrieve it using my Grafana dashboard. And as you can see over here, the data is coming in, and there are a number of different dashboards you can take a look at to see the trends in the Twitter for these 3 keywords that I'm interested in. So to summarize, this project was very interesting, especially because I was able to create everything using AWS clusters and make it communicate with each other. On top of the required 3 tiers, I've actually implemented 4, just to be able to show more end-to-end pipeline implementation. And I also used a number of new technologies that we have not explored in the homework. One being the Twitter Flume source that wasn't very helpful in the beginning. Another one being the ES Hadoop, which is an Elasticsearch streaming connector. And finally, Grafana. So this is my project. Again, thank you for listening. Thank you for your time. Let me know if you have any questions.